क्लासिकल मैकेनिक्स के वेरी मोस्ट इंपॉर्टेंट एमसीक्यूज फॉर क्लास बीएससी एमएससी। चैप्टर नंबर 2 क्लासिकल मैकेनिक्स इन लैग्रेंजियन फॉर्मूलेशन। तो वीडियो को एंड तक देखिएगा, साथ साथ मैं एमसीक्यूज को एक्सप्लेन करूंगा, आंसर भी साथ साथ बताऊंगा। तो उम्मीद करता हूं कि ये वीडियो आपकी एग्जाम में काफी हेल्प करेगी। क्वेश्चन नंबर 1, द मिनिमम नंबर ऑफ म्यूचुअली इंडिपेंडेंट कोऑर्डिनेट्स required to completely describe the configuration of a mechanical system are called as dash coordinates. ऑप्शन देख लेते हैं। साइक्लिक, क्वार्टिजन, पोलर, जनरलाइज्ड, इग्नोरेबल। The right answer is generalized coordinates. फर्स्ट का करेक्ट आंसर है जनरलाइज्ड। नेक्स्ट क्वेश्चन नंबर 2, the number of degrees of freedom of a free particle are dash. किसी भी फ्री पार्टिकल की नंबर ऑफ डिग्री ऑफ फ्रीडम जो होती है वो 3 होती है। नेक्स्ट क्वेश्चन नंबर 3, the number of degree of freedom of a projectile constrained to move on a plane xy plane are dash. The correct answer is 2. Next question number 4, the number of degree of freedom of a particle constrained to move on a curve, straight line or a curved line. Very important. The right answer is 1. 1, 2, 3 and 4. तो ऑप्शन में जो राइट आंसर है वो है 1 फॉर द particle to move on a curve. Next question number 5, the number of degree of freedom of a train moving on its rail are. तो नंबर ऑफ डिग्री ऑफ फ्रीडम बताना है यहाँ पे। जब एक ट्रेन मूव करती है रेल के ऊपर, रेलगाड़ी की पटरी के ऊपर जब मूव करती है तो उस वक्त उसकी जो नंबर ऑफ डिग्री ऑफ फ्रीडम होगी वो कितनी होगी। तो राइट आंसर इज, ऑप्शन देख लेते हैं 1, 2, 3 and 4. The correct answer is 1. Question number 6, the number of degree of a simple pendulum are. Right answer is 1. Question number 7, the number of degree of a double pendulum are. The right answer is 2. Double pendulum की degree of freedom 2 होती है। Question number 8, the number of degree of Atwood's machine are. The right answer is 1. Question number 9, the number of degree of a compound pendulum are. The right answer is 1. तो यहाँ पे मैंने साथ साथ इसका सॉल्यूशन भी लिखा हुआ है, तो यहाँ से भी आप देख सकते हैं। नेक्स्ट बात करते हैं क्वेश्चन नंबर 10 की। जनरलाइज्ड कोऑर्डिनेट आर रिप्रेजेंटेड बाय डैश। द राइट आंसर इज QJ. This is the right answer. Question number 11, generalized velocities are represented by dash. Correct answer is QJ, PJ. These are two here. First, these two are here. Question number 12, generalized coordinates QJ. The right answer is are independent of one another. Next, question number 13, number of generalized coordinate is always dash to the number of degree of freedom. ऑप्शन यहाँ पे देख लेते हैं, लेस देन, ग्रेटर देन, इक्वल टू, मे बी लेस देन और ग्रेटर। द राइट आंसर इज equal to. Equal to is the right option here. Next question number 14, if there are n particles of a system and there are no constraints on it, then the number of degree of freedom of this system are very important. The right answer is 3n. 3n number of degree of this system. Next, question number 15. If there are n particles of a system and there are k constraint imposed on this system, then the number of degree of freedom of the system are. The right answer is simple 3n minus this k. Next, question number 16. For an n particle system with no constraints, the number of generalized coordinates required to describe the system are dash. The correct answer is simple 3n. Next, question number 17. For an n particle system with k holonomic constraints, the number of the generalized constraints coordinates required to completely describe the system are. The right answer is 3n minus k. This k. तो यहाँ पे इसके आंसर्स मैंने लिखे हुए हैं, यहाँ से भी आप देख सकते हैं. नेक्स्ट वेरी इंपॉर्टेंट एमसीक्यूज आप लोगों के साथ मैं यहाँ पे शेयर कर रहा हूँ, तो इन एमसीक्यूज को कीजिएगा, क्लासिकल के इंपॉर्टेंट है. तो नेक्स्ट बात करते हैं क्वेश्चन नंबर 18. वन होलोनोमिक कांस्टेंट डिक्रीजेस the number of degrees of freedom by dash. The right answer is, ऑप्शन देख लेते हैं, 1 2 3 4. Correct answer is 1. Question number 19. If two holonomic constraints are applied on a system which had initially 12 degrees of freedom, then after the application of two constraints, the number of degrees of the freedom are. ऑप्शन देख लेते हैं, 14, 12, 10 and 2. The right answer is 10. According to this statement, 10. 12 minus 2, 10. Next, question number 20. The constraints which can be written in the form of an equation f into q j dash t into is equal to 0 when is equal to 0 are f into q1 q2 q3 up to so on qn multiplied by t into is equal to 0. The important thing, equal to 0 then are called as dash constraint. Very important MCQs. The right answer is holonomic constraints. When equal to 0, then holonomic constraints. And similarly, question number 21, the constraint which cannot be written in the form of an equation f into qj comma t into is equal to 0 or f into q1 q2 q3 up to so on qn multiplied by t into is equal to 0. Important thing, equal to 0. It means equal to 0 cannot be written. So this constraint is known as non-holonomic constraint. Simple definition. Very, very important. MCQs number 22. The constraints expressed as f into qj into is equal to 0 are f into q1, q2, q3 up to so on qn is into is equal to 0. Here not t. Noted that here is the t, here not t, are called as dash constraint. 22 is known as Saccharomyces constraints. Next, question number 23. The constraint which cannot be explicit clear function of time, don't explicitly depend upon time are called as dash constraint. The right answer is Saccharomyces Question number 24. Cyclotomius constants are expressed as dash. The right answer is F into Q J into is equal to 0. This is the right answer. Next, question number 25. The constant represented as inequalities like F into Qj, comma T into greater than equal to 0 are called as dash constants, non-holonomic constants. Question number 26. The set of positions or coordinate of all the particle of a system Q1, Q2, Q3 up to so on Qn is called as, the right answer is configurations. Next, question number 27, generalized coordinates. The right answer is may have dimensions of the length or even dimensions of the momentum, energy, etc. Question number 28, the number of degree of freedom and hence number of the generalized coordinate of a rod lying on the plane surface are option 1, 2, 3 and 4. The right answer is 3. Question number 29, the number of degree of freedom hence generalized coordinate of a simple pendulum dash r dash. The right answer is option 1, 2, 3 and 4. Correct answer is 1. Question number 36. Question number 30. The number of degree of freedom hence generalized coordinate of a particle constrained to move on a circular path r dash. Option 1, 2, 3 and 4. The right answer is 1. Any particle constrained to move on a curve of any shape. Next, question number 31. The number of degree of freedom of a particle hence the generalized coordinate which is constrained to move on the surface of the sphere r dash. Correct answer is option 1, 2, 3 and 4. The right answer is 2. In this case, surface of a sphere are 2. Question number 32. A bead constraints to move on a curve has dash degree of freedom. The right answer is 1 degree of freedom. Next, question number 33. The number of the generalized coordinates required to completely describe the configuration of a single free particle is dash. The right answer is very important 3. Question number 34. A particle or a ball constraints to move on the table surface has dash degree of freedom. Very important. The right answer is option given 1, 2 and 3, 4. The right answer is 34 का right answer है 2. Question number 35. Two balls are fixed at the two ends of rod. The constants on them is dash. The right answer is 35 का right answer है holonomic. This is the right answer. Question number 36. If a gas is enclosed in the spherical shell, then the constants on the gas molecules is dash. The right answer is non-holonomic constants. Question number 37. Constants on a simple pendulum x square plus y square is equal to L square is dash. The right answer is holonomic constants. This is the circle equation. Next, question number 38. A rigid body is an example of. The right answer is a system with holonomic constants. Next, question number 39. The holonomic constants of a type of f into q1, q2, q3 up to so on q1 multiplied by t is equal to 0 are called as dash, and the holonomic constants of the type f into q1 q2 q3 up to so on qn into is equal to 0 are called dash. The right answer is Cycloromius. Next, question number 40. Difficulties produced by the constraints. The right answer is first difficulty is produced. Question number 41. How to remove the two difficulties caused by the constraints? The right answer is next, question number 42. If the forces of the constants are to be determined, we use. The right answer is Lagrangian multiplers. Question number 43. Are generalized coordinate interlinked by the constants or they are independent of the constants? The correct answer is independent of the constants. This is the right answer. Question number 44. The time delta t taken by the virtual displacement is. The right answer of the 44 question, 0. Virtual displacement, so 0. Question number 45. Virtual displacement is dash displacement. The right answer is imaginary displacement. This is the right answer. Option real, imaginary, large, small, imaginary displacement. Question number 46. Virtual displacement is always dash. The right answer is obey the constraints. This is the right answer. Question number 47. The work done by the forces of the constants on any virtual displacement is dash. Maximum, 0, positive, negative. The right answer is 0. Next, question number 48. If total virtual work done by all the external forces over all possible virtual displacement is 0, then the body is said to be dash, and this principle is called as. The right answer is static equilibrium. And this principle is known as principle of the virtual work. Next, question number 49. Principle of virtual work is written as. 49 का correct answer है the principle of the virtual work. Next, question number 50. The principle of virtual work is related to dash equilibrium, while the D'Alembert principle is related to dash equilibrium. The right answer is static equilibrium. And while the D'Alembert principle is related to dash equilibrium, the right answer is dynamic equilibrium. Next, question number 51. Generalized coordinates qj, generalized velocities qj dot. According to this statement, second is the right answer. Question number 52. The unit of the generalized velocity are. Correct answer is maybe meter per second. Question number 53. Generalized force capital Qj. Question number 54. Mathematical form of the D'Alembert principle. Very important statement. लास्ट टाइम पीपीएससी के लेक्चरर फिजिक्स के एग्जाम में ये एमसीक्यूज पूछा हुआ था. 54 का जो करेक्ट आंसर है, ए सिस्टम इज इन द डायनामिक इक्विलिब्रियम इफ सिग्मा n I approaches to 1 f I a bar minus p I bar dot into delta r I bar is equal to 0. सिंपल D'Alembert प्रिंसिपल कि ये देख लीजिएगा, ये इसकी मैथमेटिकली फॉर्म है. एमसीक्यूज नंबर 55. इन D'Alembert प्रिंसिपल f I bar is the dash and pi bar dot is the dash. According to this, the right option of the question 55, Fi bar applied forces, Pi bar dot internal force. Question number 56, generalized form of the Lagrangian equation of the motion. The right answer is simple, d over dt into partial t over partial qi j into minus partial t over partial qj is equal to capital J. Question number 57, Lagrangian equation for the conservative system. The right answer is d over dt into partial L over partial qi q dot j into minus partial L over partial q j is equal to 0. This is the Lagrangian equation for the conservative system. Question number 58. In the general form of the Lagrangian equation of the motion qj represent the dash. Correct answer is capital J, capital Q, small j is equal to generalized force. Generalized force represent the generalized force. Next question number 59. In the Lagrangian equation, j runs from 1 to dash. The correct answer is j is equal to 1, 2, 3, 4, 5 up to n. Question number 16. In the definition of the generalized force, qj is equal to, in this mathematically form, n represent the number of the particle in the system where n is equal to 3n minus k. Degree of the freedom of the system of n particle with k holonomic constants. इसके साथ मैंने रीजन भी लिखी है, लास्ट में इसके आंसर्स भी देख लेना आप कंफर्मेशन के लिए, लेकिन साथ साथ मैं बता रहा हूं आपको. Next question number 61. If 5 holonomic constants are imposed on a system of 10 particles, then its degree of freedom are. The right answer is number of degree of the freedom 3n minus k. So 3 into 10 minus 5 is equal to 25 is the right answer. Next question number 62. Dot cancellation principle is. The right answer is simple, partial ri bar divided by partial qj is equal to partial ri bar dot divided by partial qj dot. Simple. Question number 63. The Lagrange L is defined as, very, very important. The right answer is L is equal to T minus V. Next, question number 64. The number of Lagrangian equation of a motion is always. According to this, the right answer is number of the degree of freedom. 4 is the right answer. Question number 65. A system has 2 particle and 2 holonomic constants. How many Lagrange equation of the motion will describe its motion? Very important. The right answer is number of the generalized coordinate is equal to number of degree of freedom. So the number of Lagrange equation of the motion will be the 4. Next, question number 66. A conservative force is always equal to. Option देख लेते हैं. Curl of the same vector function, divergence of the same vector function, gradient of the same vector function, gradient of the same scalar function. So 4 is the right answer. Next, question number 67. Find the Lagrangian L of a simple pendulum, a compound pendulum, a free particle in 3DL shape, Edwards machine, a particle moving on the plane in the force free region, a double pendulum. तो सिंपल यहाँ पे Lagrangian यहाँ पे L फाइंड करना है, तो इसके मुताबिक वो पीछे बात कर चुके हैं, तो वहां से देख लीजिएगा। नेक्स्ट क्वेश्चन नंबर 68, ड्राइव द लैग्रेंजियन इक्वेशन ऑफ द मोशन ऑफ द सिंपल हार्मोनिक ऑसिलेटर। तो ये भी इम्पोर्टेंट क्वेश्चन है, लॉन्ग क्वेश्चन है, तो इसको भी आप देख लीजिएगा नोट से, मैं नेक्स्ट आप लोगों के साथ शेयर करूंगा। तो ये तो थे क्वेश्चंस के आंसर्स, यहाँ से इसको टैली कर सकते हैं जो जो मैंने साथ साथ बताए हैं। साथ साथ मैंने कुछ क्वेश्चंस की रीजन भी लिखी है। तो उम्मीद करता हूँ कि आज की वीडियो आपको काफी हेल्प करेगी। तो ये इसके आंसर्स हैं। इंशाल्लाह इसी तरह नेक्स्ट क्लासिकल फिजिक्स को लेके चलेंगे, ताकि ये लॉन्ग क्वेश्चन स्टार्ट हो गए हैं। लास्ट में 2 मैंने क्वेश्चंस आप लोगों के साथ शेयर किए थे, उनके आंसर यहाँ पे अवेलेबल हैं। तो नेक्स्ट इंशाल्लाह हम लेके चलेंगे चैप्टर नंबर 3 एमसीक्यूज क्लासिकल मैकेनिक्स इन दी हैमिल्टनियन फॉर्मूलेशंस। तो पहले हमने लैग्रेंजिंग की बात की थी, अब हम हैमिल्टनियन फॉर्मूलेशन की बात करेंगे। तो इंशाल्लाह इसके एमसीक्यू डिस्कस करेंगे। तो ये अक्सर वेरी इंपॉर्टेंट है, लैग्रेंज एंड हैमिल्टनियन। तो इन दोनों के एमसीक्यूज आप लोगों के साथ मैं डिस्कस करूंगा। फर्स्ट फेज में डिस्कस कर चुका हूँ लैग्रेंज के, तो नेक्स्ट हम लेके चलेंगे हैमिल्टोनियन। तो इंशाल्लाह मिलते हैं नेक्स्ट वीडियो में। अल्लाह हाफिज।